Hello, my name is Matthew Landis. I watched the Planet 9 from Outer Space lecture given by Caltech professor Konstantin Batygin. In the background, I will be playing the first few minutes of the talk while I discuss my thoughts. In this lecture, he explains some of the history behind the discovery of the orbit of Neptune, as well as the existence of Pluto altogether. To preface my summary and analysis of this lecture, allow me to explain the extent of my knowledge on this topic. Although I've always wanted to be a CS major, I've been fascinated by the stars and planetary motion. This means I've bought books on astrophysics and listened to lectures by Stephen Hawking and Neil deGrasse Tyson. However, I've mostly learned about the general universe as a whole, rather than our solar system or the planets or other celestial bodies in it. This means that most of this lecture was all new information to me. One of the first things I learned was how far back astronomers were not only aware of the existence of some of the celestial bodies, such as Neptune, but even more how they were able to accurately generate semi-accurate predictions of planetary motion, as well as a result, the mass of these planets. Urban Leverrier and John C. Adams were able to use the tools and knowledge of their time to predict the motion and mass of Neptune as far back as 1846. One of the interesting points regarding their discovery is the dependence on the time of their observation. Because they were living in the 1830s, they were able to watch while Uranus and Neptune were quite close to one another. This is relevant because the bodies have an influence on one another, and as a result, they were able to get a more accurate prediction than if we were to follow the same steps today. Something that I had heard that I had already known was that the planetary potential existence of a ninth planet in the solar system. This is possible because it would simply be orbiting at such a significant distance away from the Sun that it has simply not been acknowledged to be caught in the orbit of the Sun. If this current predictions are correct, the motion of this possible planet has an orbit hundreds of times that of Neptune. Additionally, the same way that we were able to take us orbital position data and theorize the mass of a celestial body as part of the lab, scientists have done the same and predict that this planet would be about 80% of the mass of Neptune, still making it many times more massive than the Earth. One of the parts of the lecture that truly caught my attention was the fact that we could have simply been missing this additional planet altogether, simply as a result of the fact of its position and distance would have made it too dim to have been noticed by astronomers using current telescopes. This sparked my curiosity because the idea that there could be additional objects of potentially massive sizes also caught in the Sun's orbit, following the same motion as ours, even if just a bit slower and further away, and all this time we would simply not have been aware of its existence. Although these planets would be absolutely outside of the Goldilocks zone and likely not be harboring life, they still could offer fascinating information regarding the creation of our solar system. Something that places this lecture as relevant to my major is the computational models that are required to make many of the extremely complex predictions that are relied upon to better understand planetary motion of both unknown and potentially unknown planetary bodies. These models likely require significant quantities of development time to make them both accurate and efficient. It is always interesting to consider how these applications of technology permit calculations that would have never been feasible before. One of the ways that I've followed up on this topic after watching the lecture is looking into the methods that were used to calculate the distance of observed celestial bodies. I have found an article by Las Cumbres Observatory, which I will link as part of my submission, where they explain the parallax effect, how it is used to accomplish exactly this. Simply put, astronomers used the combined motion of the Earth with the motion of the body to compare the changes of each using the distant stars as scales to determine their motion. And as a result, they're able to solve for the distance of the body. Thank you.